Hello, my viewers. You are welcome to Understanding Chemistry by Nkechi. Today's lesson we'll be looking at a second order reaction and calculations involving order of reaction and rate law. So, second order reaction. These are reactions in which the rate of reaction is directly proportional to the product of concentration of species in a rate law, and the sum of the exponential function of the species is equal to 2. You can see the order of reaction is second with respect to what? A. So, if you have only the reactant, that A will raise to the power what? 2, which is the order of the reaction. So, if I have another reactant, if I have two reactants, A plus B, to give product. So, you can see the rate is equal to rate constant, product of rate constant, multiply the concentration of A and B raised to the power 1, 1. So, it means that this one, the order of this reaction is 1. With respect to what? A. B is what? First order reaction. So when you sum them together, 1 plus 1, overall order reaction will be what? Will be 2. Let's look at formula for second order reaction. So the formula for second order reaction, inverse of initial concentration. Initial concentration. So this one is concentration at time t. Concentration at time t. So concentration at time. So K, as you know, is what? Specific rate constant or rate constant. So if you have to plot a graph of for second order reaction, I will use this. So as you can see, this is slope. The slope of the graph will be equal to what? K. Rate constant slope will be equal to what? K. Positive K. Zero order and first order reaction, their slope is equal to minus K. Look at the representation of so you can see the positive slope. Okay. So this equation I have here is when the product is, you have only one reactant. So that's for this. But the one that you have the two reactants A and B, that one is actually complicated. So we'll not be considering it at this level. So slope is equal to K. The general formula for order of reaction is this molecular symbol that is representing mole per liter or mole per dm cube. So 1 minus n per seconds. So this per seconds is constant in all the other orders of reaction, from 0 to all the orders of reaction. This one is constant. So this n represents order of reaction. 1 minus 2. So if the order of reaction is second, so 1 minus 2 is what? Minus 1. So the unit is, so this is the unit for second order reaction. Remember, this time is in seconds. It can also be minutes, it can also be hour per hour, it can also be in year, depending what I given the question is. So if you want to, what if maybe the question is the unit is required in mole per liter, not just this m, mole per liter or mole per dm cube. So 1 over m, this m, I'll just leave this one now. At the end of this thing, I'll put the seconds there. So this 1 over m, and this 1 over m is something as 1 divided by what? So 1 divided by, what is m? Mole per liter over liter. So if I put multiplication sign, I'm going to inverse this. So something as saying liter, if I bring this in up per mole, then this is constant, I'll bring it, this one is constant in all. So the unit for second order reaction is liter per mole per seconds. Anytime you are confused, you just use this 1 minus n. So with this you can do third order reaction. Even though not considering the third order reaction, if you ask the unit for third order reaction, 1 minus 3, so you have a minus 2. So let's look at this question. A second order reaction has a rate constant 1.15 times 10 to the power minus 3. How long will 0.1 mole of this reactant take to reduce to 0.075? So this is the formula for second order reaction. We're actually looking for time. So the initial concentration is 0.1. The final concentration or concentration at time is what? 0.075. So we have to make time the subject of formula. So our T is equals to 1 over minus all over K. So when you make T so the formula, you'll be having this. So we have 1 over what's our concentration at time is 0.075 minus 1 over 0.1 divided by 1.1 times 10. 1.15 times 10 times 10 raised to the power minus 3. So T is equals to, so when you divide this, you're having a 13.3 minus inverse of 0.1 is 10 all over 1.15 times 10 raised to the power minus 3. So by the time you solve this, you'll be having a 3.3 divided by 1.15 times 10 raised to the power minus 3. So your answer is going to be 2870 seconds. It means that it takes 2,870 seconds for 0.1 mole of this reactant to reduce to 0.075. So before we go to more calculation, let's look at a pseudo order reaction. What's a pseudo order reaction? A pseudo order reaction is a reaction in which one of the reactants is in excess amount, such that the concentration of the reactant is independent of the concentration of that reactant which is in excess amount. Instead, the concentration of the reactant depends on the species of the reactant that's what is small amount. That's what we call limiting reagent. Okay, look at this. The reaction hydrolysis of methyl acetate. That's something as methyl ethanoate. So hydrolysis of this, water is in large excess amount, water is in excess amount. So the concentration of water of that reaction of the reactant does not depend on the one of water. Instead, it depends on the one of methyl ethanoate. So for that order of reaction, rate is equals to, so we use a instead to designate it. So this is the rate constant. So the concentration of, since water is large excess amount, it does not depend on the one of water. Instead, it depends on this. So you have so you can say that this is a pseudo first order reaction, because it's just about 1. So this is pseudo first order reaction. So let's look at this question. A reaction is second order with respect to a reactant. How is the rate of reaction affected if the concentration of the reactant is doubled? If the concentration of the reactant is reduced to half. So let the concentration of the reactant let it be Let it be what? A. You can use any letter of your choice. Let it be A. So let it be what? A. Okay. So for second reaction, other reaction, rate is equals to, it should be what? Raised to power what? 2. So this is for second order reaction. And we are told that if the concentration of the reactant is doubled, so that's 2 times of the what? Concentration of the reactant. So rate is going to be, so you have 2a raised to power 2. So we should be having, so 2 square is 4. So what I have here, 4. What of the square of A is what? So rate, number, bring the number first. 4k A square. So what it means that if you double the concentration of the reactant, the rate of reaction is going to increase by 4 times. So the rate of reaction is going to increase by 4 times. 4R. The concentration is reduced to half. So the same half rate equals to K. If this one is reduced to half, so what it means that, so 1/2 reduced to half, so have K is equals to, the square of this, we're having a 1/4 A square. So rate is equals to, will be, so it means that if I reduce the concentration of this reactant by half, the rate of reaction is going to reduce by 1/4. 1/4 times, that's what it means. So 1/4 of the rate, so it's going to be 1/4 of what rate of the reaction. Let's look at this question. Reaction between A and B is first order with respect to A and first order with respect to B. Complete the table below. Complete it. So let's look at the rate. Write the rate law for this. So K, we are told that the reaction is first order with respect to A and first order with respect to what? Reactant B. So if I put 1, system, so this is what I have. So this is rate law. There are 2 ways of solving this. If you want, there are 2 ways of solving this. You can still get the same answer. Okay, look at this. Since K, we can find K using this formula. We can find K. So what should be the K? K will be rate all over concentration of what? A all over that of what? B. For this one, you can only use the one that have the initial concentration of the one for A and B is given. You cannot come and use this one because this one is missing. This one is missing. This one is missing. So we use the one that's complete. Everything is complete. So rate here is 0.002 divided by product of the reactant 0.1 by 0.1. So when you solve that, K is going to be 0.0002. 0.02. So unit of rate constant for second order reaction is liter per mole per seconds. So since I've gotten our K, so it means that to find this one will not be easy, it will be simple. You just substitute using this formula, just substitute here. Since I find K, remember this K, this rate constant is the same. If you use experiment 1, it's the same for all the experiments. is the same value. Experiment 2. So rate so for experiment 2 we are looking for condition for A is what I'm looking for. So what I'm going to do is to make this one sort of formula. So the one for A will now be rate all over K times B. And our rate is 0.02. 0.02 all over. Sorry. What's the rate for experiment 2? 0.0004. Our rate constant is 0.02. 0.02 times, what's the one for B? Experiment 2, the B is 0.2. So we're having, so what we have is 0.1 mole per liter. So here I got 0.1. You feel it? So here is 0.1. So do the same for all of them. So in this case, for experiment 3, we are looking for rates. We are looking for rate for experiment 3. So rate is equals to, let me call it R3. R3 is equals to, what's the rate constant? Rate constant is 0.02 times. So for experiment 3, I have 0.3 for condition of what? A. Times 0.3 for condition of what? Of B. So 0.018. For experiment 4, we are looking for condition of B. So I'm going to make this one instead of formula. So condition of B is equals to rate all over rate constant multiplied by condition of what? A. So what is the rate for experiment 4? 0.0002. So what's the value for rate constant? 0.02. What's the one for A? 0.2. 0.05. So 0.05. So it's not what to do guesswork. If this one is 0.1, okay, this one is 0.2. 0.3 will be 0.4. It's not like that. So that's also another method you can use to solve this. If you don't want to find this method I use, I found the first of all calculated the rate constant K, which I use and substitute and be solving. So if you want to follow that way, if you follow this one, look at this rate. This rate is equals to K then I can say, okay, equate rate. I can use either rate 1, okay, this or this, or any of the one that has the initial rate, I can use it. So rate 1, let me use R1 and experiment 1 and experiment 2 for it. You can use any one. I'm using experiment 1 and experiment 2. Remember, there was nothing here before. No value was here. Found here. No value was here. Okay, so R2, I always like to place the higher number. Since this rate, initial rate is higher than the one experiment 2 is higher than the one of experiment 1. Even if you put the other one lesser 1, you still get the same answer. So R2 over R1 is equals to K all over. So of course I'm going to eliminate K. So I'm going to substitute it. What's the value for R2? 0.0004. R1 is 0.0002 equals to, what's the condition for A? 0.1. The one for B is 0.1. So this one is missing. It's missing. So Then the one for B is 0.2. So I'm looking for A, concentration of A. So I make a set of formulas. So this times this divided by this. So 0.0002 times 0.1 times 0.1 all over 0.0004 times 0.2. By the time we sum this into multiply this and divide by the denominator, you'll be also be getting was 0.1. So they're using this method. This method that we don't need finding K. But the first one I solved. So finding K using the one that has complete table, this is complete. We were unable to do what? To fill the table with ease. So any method I want to use, no problem. So let's look at this exercise. The following data was obtained for an arbitrary reaction B2 plus 2C to give 2BC. So this is experiment 1, 2, 3. This is the initial concentration for B and C. This is the initial rate. So we are asked to calculate the order of reaction with respect to B. Order of reaction with respect to C. Number 3, the overall order of the reaction. C. Number 4, calculate the specific rate constant. So we're going to take them one after the other. So very simple calculation. All right, let's start. Question number 1, calculate the rate, the order of reaction with respect to B. So rate is equals to, we put this. So for the question, I have B and C. So this is the equation. We're looking for the order of reaction actually. So for the position of B, I will use S. The one of C, I will not put that too. See the equation we are given. So let me write it out. So I will not just put these two. Since we are looking for the order of reaction, so I will use letter X for this. I use letter what? Y. You can use any letter of your choice. Okay, so this is the rate law. So I'm looking for order of reaction for B. So look at this B. I'm going to put something that is going to eliminate C. Eliminate C so that I have only what? B to work to find my answer. Okay, look at this. In C, I have two numbers that are the same. 0.01 in experiment 1 and experiment 3 they are the same. So I'm going to pick it. It has to enable me to eliminate C. So using experiment 1 and 3. Experiment 1 and 3. Okay. So for me, I always go with the one that's number is higher, but you see have the same answer. So that's how I quickly look at, okay, 1 and 3. This number is bigger than this number. Also, this one is also higher than this. So of course, I'm going to eliminate K. We'll go out of the equation. Let me clean this board. The wider space. All right. So what's the value for R3? 5.7 times 10 raised to the power minus 3. The value for R1 is 1.43 times 10 raised to the power minus 3. So what's our B? This is BC. B and C. So for experiment 3, what is B? 0.08. Experiment C is what? 0.015 raised to the power Y. So over for experiment 1, what's my B? 0.04 x. Experiment 1 for C, 0.015 raised to the power 1. So as you can see, this and this will be eliminated at the same to cancel out. 5.72 times 10 raised to the power minus 3 over 1.43 times 10 raised to the power 3. So I'll be having 4. So we'll be having 4 is equals to, so look at this, 0.04 divide 0.08 to having 2. So what it means is something as saying 2 times 0.04. This value 0.08 is something as 2 times 0.04. 0.04 raised to the power x. So 4 is equals to, so this 2 raised to the power x times 0.04 raised to the power x. So 0.04 raised to the power x. So this is the one for, so since these two are the same, if you cancel out, they are the same. So at the end, I'm having 4 is equals to 2 raised to the power x. Of course, 4 is something that's for 2 raised to the power 2 is equals to 2x. So these two will cancel each other. So what is the value for our x? 2 is equals to x. So x is equals to what? 2. So it means that the order of reaction with respect to b is what? Is this x. This is the order of reaction for x. This is the order of reaction for, so this is the order of reaction for b. This is the order of reaction for c. So it means the order of reaction for with respect to b is what? 2. Like I said, if we use the coefficient experiment to know, and let's solve this. So I've gotten our b. So I'll make a statement that, so therefore the order of reaction, the order of reaction with respect to b is 2. You just put that statement in your book. I don't want to clean this formula because this is a general formula for all of them. All right. So let's look at order of reaction with respect to C. Looking for C, so I'm going to eliminate B by using the same value that are the same, 0.04, 0.04, so that I can do what? Eliminate what? B. Then it means I'm using experiment 1 and 2. That's what it means. So for this C, I'm using this and this. So this value is higher than this. So I'll go with R2 over R1. Like I said, if I put R1 here, why don't you attempt it? So what you just need to do, okay, what if I use R1? Let me use R1 and do my own. If you get the same value. Alright. So B raised to the power x, C raised to the power y. So I have K, B raised to the power x, C raised to the power y. So this K will be eliminated because, alright, so what's R2? 2.86 times 10 raised to the power minus 3 all over 1.43 times 10 raised to the power minus 3 is equals to, so what's concentration for B in experiment 2 is 0.04. So 0.04 raised to the power x. The one for experiment 2 for C is 0.03 raised to the power y. So for B, experiment 2 for B is 0.04 raised to the power x. And 1, so 0.015 raised to the power y. So what's next I'm going to do? So remember, this will cancel out, to cancel out. So this divided by this will give me, I'll be having a 2. So 2 is equals to 0.03 y all over 0.015 y. Of course, if you divide this will give you 2. So it's something like saying 2 times 0.015 raised to the power y all over 0.015 raised to the power what? Y. So let me clean this side since I've already, let me clean here. So when you do this, 2 is equals to, of course, if it's If it's a objective question, maybe I have to fill the table. What's the order of reaction with regard to this? You don't really need to go into this solving. From here, you should need to know what the answer is from here. You know that already this will eliminate this. 2 is equals to 2y. Of course, the answer will give you 1. But if it's a story question, we can take our time and solve. But 2y, 0.015 raised to the power what? Y. All over 0.015y. So of course, this and this will go out. So you are left with 2 is equals to 2y. Of course, 2y is something I say 2 raised to the power 1 equals to 2y. So 2 will cancel out 2. Y is equals to what? 1. So it means that the order of reaction with respect to C is 1. So make a statement, therefore, the order of reaction with respect to C is 1. So the overall order of reaction, so therefore the overall order of reaction equals to x plus y, and our s is what? 2, y is equals to 1. So the overall order of reaction is what? 3. So this is the third order reaction. So next question is specific rate constant. Calculate the specific rate constant. Make this K. I'll set the formula. K is equals to the rate, okay, all over b raised to the power 2c. So for R1 is so R1 is, well, in experiment 1 is equals to 1.43 times 10 raised to the power minus 3 all over. So what's B? What's the one for B1? B is what? That's 0.04 raised to the power 2 multiplied by the one for C, 0.05, 0.015. So K is equals to 1.43 times 10 raised to the power minus 3. 0.43 times 10 raised to the power minus 3. 2.4 times 10 raised to the power minus 5. So K will be what? K is 59.58. So the issue is, what should be the unit of K? K is not unitless. Since the overall order of reaction is third order reaction, like I told you, your units, if you have m, 1 minus n per seconds. So the order of reaction is third order. So 1 minus 3 will give you minus 2. So the unit is per seconds. Or what if you expected to put the answer in maybe mole per liter, mole per dm cube? 1 over, this one is constant. Let me just work with it. So instead of saying 1 divided by mole, this is mole square per liter square. So 1 times, when I put times, I'll invert it. So the unit is also what? It's also 59.58 liter square per mole square per seconds. So if it's dm cube, remember dm cube, now we are squaring it. So square of 3 is what? 9. Will have been, so have been, so if it's dm cube, 59.58 mole per square per seconds. So this unit is very, very important. The unit of your rate constant, very important. So once you know this, 1 minus n, you don't need to stress yourself. You just put this or this or this, either of them. Fourth order, 1 minus 4. Alright. So I want to say something again. In some cases, they might not ask you to find the overall order of reaction. They will just ask you to find the rate law. Determine the rate law and rate constant. Rate law and rate constant. Okay, look at this. When you write this, rate is equals to, you now put your k. For example, put a, you raise to the power x, and b, raise to the power y. So this is the rate law. But you have to find the order of reaction. You have to find this x and find this y. Follow the procedure, what we did. At the end, if your x, for example, look at this one, our x, we got 2, and this one is 1. So this is the rate law. 2 questions, find the rate law and the rate constant. Nobody asks you to find the order of reaction, but you must find the order of reaction first. You must find what this x, what it means, and what this y means by following that method we use to find s and y. When you find this order of reaction, you now substitute it. Okay, if I have to, I put 2. So this is the rate law. This expression is what we call rate law. Then specific rate constant. Of course, use your maybe experimental one, anyone. You made this one solve the formula. Put this simple. Before I end this lesson, I have a practice question for you. You know when you answer it, post your answer in the comment section. So I'll see it and commend you. Okay, look at this. A reaction is second order with respect to a reactant A. How is the rate of reaction affected if the concentration of reactant A is tripled? Of reactant A is tripled. So next video I'll be uploading will be on half-life for 0 order, first order, and second order. Okay, we've come to the end of this video. If you have not subscribed to my channel, kindly do that and share it and like. Thank you for watching. Do have a great day. Bye.